Hello students, I wanted to offer some assistance with Chapter 2 homework. Not really too bad, but there might be a few times when you look at it and say, I'm not quite sure how to set this up. So just a little intuitive setup advice for you here. I pulled out some of the questions, not necessarily the ones you'll see, however, you can get the idea from these. So I'll start with the first one with the bar graph, and you'll see this image in your homework. It says in 2015, the world's total output was 80 trillion. What percentage of this was produced by the three largest economies or some other combination? And I want to just show you, there's a really easy trick for setting up questions like this. Think of it as a ratio. A ratio relates one thing to another, and you usually see a ratio, with a number up here and a number down there. And it's about the relationship between the two numbers. Well, you can set a problem like this up as a ratio. And so we'll put the total population of whatever you're trying to understand on the bottom, and then the top number will be the relationship between a part of the population and the total. So this example then would say, well, you've got a world output of 80 trillion. That's the total of all of the combinations of this world output, this GDP. And then the question is, what percentage was produced, that's our ratio, by the three largest economies. So in this example, we'd say, well, the three largest are the U.S., and we've got the numbers here. Add this up, and we get 33.4 billion. It's important to watch for billion to billion a ratio here. We want to make sure our numbers are accurate. And in this case, it's 334 billion out of 80 billion. So we put our total on the bottom and our portion on the top, and we can just solve it. Now it's just a division problem. So go in your calculator and do it. The next one is similar to that, except that this one is how does it stack up in percentage terms, right? So we're calculating a percentage of a total. So if the percentage that we're looking at is, we're comparing it to America's per capita GDP, and we're saying, well, how does another country stack up? Well, if the question is, and I'm just going to pick one here, I'm going to pick Mexico as a country. Well, Mexico's is 9,710 billion, by the way. Out of, per capita, it's not billion, it's thousand. Out of the 55,980 that America has, and it's a ratio. We're relating those two numbers. We're saying what portion of this total is represented by this 9710. So again, we just do simple division there. You can run it through your calculator and see it easily. So I think setting it up as a ratio with the total on the bottom, the larger population on the bottom will always work when you're doing that sort of problem. Now, this next one's a little different. I want to show you this one. I strongly encourage you to be familiar with the percent change formula. It's a simple one. It's universal. You will use it a million times in your life, and you use it in this example. And they even mention what it is. They give you this formula right here. New minus old over old times 100. So they say in 1980, America's GDP per capita was 30,000 if we measured it in today's dollars. How much higher in percentage terms was America's GDP per capita in 2015? So we want to know the percentage change from 30,000 in 1980, and that's the old information. And today, the new information is 55,980. So we're going to do the percent change formula. And they give it to us here. New minus old divided by old times 100. So the new, here's my new, here's my old. So we're going to go 55,980 minus 30,000. So it makes it pretty easy. 25,980 and divided by old. All right, so that's new minus old. That's this value here. And I'm going to divide that by old. And then again, we just go right back to that ratio. Now we're comparing two numbers, but in a different way. This is a little different than the ratio we saw before because now we're calculating a change in numbers, not just a straight ratio. All right, the next one, and you may see some like this. This is how much more output does the $20 trillion U.S. economy produce when GDP increases by 1%. So that's kind of deceptively simple. It's actually simply a matter of multiplying 20 trillion times 1%. The trick here, and you may not need this help, but the trick here is to remember that you're going to take 20 trillion times 0.01. That's how you multiply it by a percentage. Okay, so that's part of it. The other part of this, a little bit trickier, is it says how much does this increase per capita income if the population is 340. So they're asking you to kind of do a couple of calculations here. And if you just keep everything organized, you can follow the steps here. You'll take your 20 trillion, and to get per capita, remember we divide by 340 million. Now watch out, because the numbers are different, right? Trillion is different than million. So if you want to just put it in your calculator, 20 trillion is, let's see, how many zeros is that? 12 zeros. And 340 million will have 6 zeros after the 340. So you can do it that way. And then, that's not all of it though, because once you have the per capita income that you get from this, then you're going to multiply that number times another 1%, because they're asking how much does it increase that value. So multiply that by 0.01, and that'll give you the number there. This next one says if Ethiopia's per capita GDP of roughly 590 were to double every decade, where would it be in 50 years? So you can do this one really easily just by kind of writing it out and taking each step. So you go 590 times 2, that's 10 years, right? Then that value times 2 in 20 years. That value that you got from the previous one times 2, 30 years, and so on. So you can do it that way. It's pretty basic, and it's just simple multiplication, and then addition, of course. U.S. real gross domestic product changed from 11 trillion to 12 trillion. They give you the values here, from 11 trillion in 1997 to 12 trillion in 2000. During that same period, the share of manufactured goods of U.S. real GDP was 12.4% in 1997 and 12.8% in 2000. What was the dollar value of manufactured output? And they give you some time frames. So in 1997, in 2000. And then how much did the dollar value change? This one is multi-step and a little bit tricky. So you're going to just start by getting some information from the problem. You've got in 1997, and I would just do it like this to keep it kind of clean, $11 trillion of GDP, and the manufacturing portion of that was 12.4%. And then in 2000, your GDP was 12.6 trillion, and your manufacturing portion of that was 12.8%. So now I think it becomes easier to see how this is all going to work together. So what you're going to do is calculate what 12.4% of $11 trillion is. And again, I reminded you before that you just multiply 11 trillion times 0.124 to convert that into a decimal. That's how you do that with a percentage. And over here with the year 2000, you're going to take 12.6 trillion multiplied by 0.128, and that'll give you the values for how much was represented by that portion of GDP for that year. And then the last part of this that makes it multi-step is that you're going to calculate the distance or the difference between these two values. And this is where you're going to use that new, and that's going to be the 2000 information, minus old, and that's going to be the 1997 information, divided by old, times 100. So you'll just take those 3 steps, and hopefully you're comfortable with each step, and then you put it together. So these get a little bit involved. Okay, so coming down to this next one, let me get rid of some information here so that you don't wonder. Let me just make this disappear. There we go. So I'm going to start over because I used some incorrect numbers before. So let's go down to this one, and it gives you the chart of per capita GDP. It gives you the average rate of growth from 2000 to 2015, and then it asks you if you are assuming that in 2016 the average rate of growth is also the rate of growth for 2016, estimate the 2016 per capita GDP. So really you're just looking at that per capita GDP at a particular rate of growth that's given to you in the chart. So in this one, let's do China, for example, and the per capita GDP in China is going to be 7,930, and you're going to find the per capita GDP rate of growth. Watch out, because this is GDP, and that's population. So it's the per capita rate of growth is set 9.8%, and you're really just going to do this. You're going to take that value, you're going to multiply it by 9.8%, and then you're going to add that value to the original. Now, that's a process you can go through. I find a much easier way to do this would be to go 7,930 times 1.098. Basically, I'm taking the 100% of it, adding that 0.098. We'd move that decimal over, you know, to multiply that. And if you do this, you're going to get that same result. That's making a two-step process a one-step process. And you would do the same for the other countries that are listed there. This, let's see, this last one, I think it's the last one, is a big old chart with lots of information. And what they want you to do is calculate the federal government share of total output. And anytime you see that, you're going to say, oh, ratio. That's going to be easy. So, and I'm just going to pick some years here. So in 19, they ask for 1996. So let's start there. So here's 1996. And the federal government's share is $527 billion out of a total GDP of 7816. So you're going to have a really easy setup here out of 7816. And you're going to solve it like that. So, and you'll do the same thing for 2006 and 2016. So you'll put the portion that you're comparing to the total. So set up that ratio. And let's see, the last one on here, I went ahead and took a look at it because I thought you might see this and think, wait, what? This one is, again, it's a little deceptive. It looks complicated. You might start looking for other information. And then if you just read it, it's actually really straightforward. And it says how much more output per year would have to be produced in the world just to provide the 3 billion severely poor population with $1 more income per day. And so you're simply going to do a calculation of 3 billion people at $1 per day more times the number of days in a year. And that number will be what you're looking for. So just watch out for that one. It's kind of an odd calculation. All right, so there you go, and I hope this is helpful to you. Let me know if you have specific questions you come up against, but you should do great.